Dear students, welcome back to a new mathematics session. In the previous session, we have discussed the basic concepts of circle and we have solved problems related to area and perimeter of circles. Hope it was clear for you all. And in today's session, we shall discuss a new concept, that is segment and sector of circle. Let's move on to the topic. Let's begin with areas of sector and segment of a circle. Before going for area, first let's consider the word sector and segment of a circle. Here, the portion or part of a circular region enclosed by two radii and an arc. Portion enclosed by two radii and an arc is called a sector of the circle. So this is a circle. And as per our definition, the region enclosed by two radii. Two radii means you can see here this is one radius and another one is this radius. And the portion enclosed between the two radii and the arc. This is our arc. This is the radii. Okay. The portion enclosed between two radii and an arc. That is called the sector of the circle. And here there are two sectors are visible. The blue colored portion is also a sector and the red colored portion also a sector, because you can see the red colored portion also the area enclosed between the arc and the two radii of the circle. So based on their size, we can define it into we can use it two different names. One is the minor sector, another one is the major sector, and this portion is called the minor sector and another portion is called the major sector. Okay, then here OAPB is called the minor sector. You can see here starting from the center OAPB means OA is the radius, AB is or APB is the arc, and OB is another radius. So OAPB is called the minor sector and OAQB is called the major sector. So here you can see starting from the center OAQ, that is on the circumference of the circle Q, and coming back to B. So OAQB is called the major sector. This is the way we just represent the sector by using different letters. Then area of the sector can be calculated by using the formula theta by 360 into pi r square. What is this theta? Theta is the angle between the two radii. Okay, angle between the two radii, that is theta. Means angle in which this arc is subtending a particular angle at the center. This particular arc is subtending a particular angle at the center, that is called theta. So theta by 360 into pi r square. Pi r square, you know that it is area of circle. Then length of an arc of a sector of angle theta. Length of the arc formula is theta by 360 into, instead of pi r square, here we have to use 2 pi r. 2 pi r means we know the circumference of circle formula. Theta by 360 into 2 pi r. So these two different formulas are very important, just to keep it in mind. Area of sector is theta by 360 into pi r square. Length of the arc means theta by 360 into 2 pi r. What is theta? Theta is the angle subtended by an arc at the center. Okay. Next we shall discuss about a segment of a circle. A segment is a region bounded by a chord and a corresponding arc. When we visualize it, see here you can see AB. AB is the chord of the circle. Chord means a line segment whose end points are on the circumference of the circle. You can see here the line segment AB, the end points of the line segment AB are on the circumference of the circle. So this is the chord, and a segment is a region bounded by a chord and a corresponding arc. See, if you take this chord AB, APB is one arc and AQB is another arc. Corresponds with the chord AB. There are two arcs it is dividing, that is one is APB, one arc, another one is AQB. As before, according to the size we can name as minor segment, another one is major segment. So APB is the minor segment and AQB is the major segment. Once again, a segment is a region bounded by a chord and the corresponding arc. So here APB is called the minor segment, APB is called the minor segment, and another one which is bigger in size, that is AQB, that is the major segment. Next, we shall discuss the exercise questions. First question from exercise 12.2. Find the area of a sector of a circle with a radius 6 cm if angle of the sector is 60 degree. Here we are asked to find out the area of sector. Radius of the circle is given to us 6 cm and angle theta is given to us 60 degree. When you visualize the question, it comes like this. Means this is the portion. That means this is the sector. Radius of the circle is given to 6 cm and the angle theta is 60 degree. So let's write the given things. Radius r is equal to 6 cm. Angle of the sector theta is 60 degree. We are asked to find out the area of sector. Theta by 360 into pi r square is the formula. Let's substitute it. Theta is 60 by 360 into pi value is 22 by 7 into 6. Radius is 6, so 6 square. And here little bit of work we can do, calculation work, that is here 60 and 366 times, okay? And here that 1 6 is there, here 2 6 out of that 1 6 is gone. That means the balance will be here 1 6 is there, here 122 is there. So 6 into 22 by denominator there is only 7. 6 into 22, let's multiply it. 6 into 22, when we multiply, we are getting 132. So just to multiply, okay, please don't copy this one. 6 2s are 12, remainder 1, 6 2s are 12 plus 1 is 13, so 132. That is 132 divided by denominator is 7 centimeter square. We can keep as it is 132 divided by 7 centimeter square. That is the area of sector. Move on to the second question. The question is find the area of a quadrant of a circle whose circumference is 22 centimeter. Here we are asked to find out the area of quadrant. Quadrant of a circle means, quadrant means 1/4 of a circle. We are asked to find out the area of 1/4 of a circle, 1/4 of the part of a circle. But circumference only given to us. Circumference is 22 centimeter. For finding the area of a quadrant of a circle, we need the radius of the circle. But radius is missing. Instead, they have given us circumference of the circle, 22 centimeter. So by using that, we are going to calculate the radius. So this is a diagrammatic representation or visualization of the question. Quadrant of a circle means 1/4 of a circle. Angle, if you take, this is 90 degree. Okay. Then it is given that circumference of the circle 2 pi r. Of course, the formula we have written, but we are going to take the given things. That is, circumference is 22 is equal to 2 pi r. Then here 2 and 22 we can cancel. Some of the cancellations we can do it left side and right side together. Here it will be coming as 11. So 11 is equal to right side pi r. So r is equal to, take this pi to the denominator. That means 11 divided by pi. Then r is equal to 11 divided by pi value is 22 by 7. That is equal to 11. Then this division we can write it as multiplication. Then multiply the reciprocal of the denominator. 22 by 7 reciprocal is 7 by 22. So 11 into 7 by 22. Here also cancellation can be done. That is, this 11 and 22 we can cancel and we can do 2 times it will be coming. Then r is equal to 7 by 2 centimeter. So better keep r is equal to 7 by 2 because this 700 we can easily cancel it later on. Then here we are asked to find out the area of quadrant. Area of quadrant is, as I said before, 1/4 of the area of circle. That is 1/4 of area of circle. We know the formula pi r square. That is 1/4 into pi value is 22 by 7 into radius. Radius is 7 by 2 square. That means 7 by 2 the whole square. Then 1/4 into 22 by 7 into 7 square means 7 into 7 divided by 2 square means 2 into 2. Then here, as before, we can do little bit of calculation work. 7, this 7 we can cancel, and here 22 we can cancel and write 11 times, and with the 2, then no more cancellation I think. Then we will be having 11 into 7, 77, 4 into 2, 8. So 77 divided by 8 centimeter square. That is the area of quadrant. Move on to the third question. The length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Here, length of the minute hand of a clock. The clock, of course, it is in circular in shape. That is length of the minute hand. That is 14 centimeter. Of course, we can consider this as the radius of the circle. Then find the area swept by the minute hand in 5 minutes. When we visualize the question like this. So the minute hand, maybe we can consider at first the position is this one, and in 5 minutes it moves from 3 to 4, means it will be covered 5 minutes. How much area it will be covered means we have to find out the area of this shaded portion. and the minute hand length is given to us 14 centimeter. Of course, that is we can consider as the radius of the circle. But for finding out the area of this portion, means this is area of sector, means it is a region bounded by the arc and the radii of the circle. That means the shaded portion area, if you want to find out, we have to know the angle. That means theta we should know. Here theta is missing. That is our first task. We have to find out theta. That means angle covered by the minute hand in 1 hour. Means the minute hand is starting from 12, and when it turns one complete rotation, when it completes one complete rotation and coming back to 12, means it will be covered 1 hour. Starting from 12 and moving 1, 2, 3, 4 up to 11, and then again coming back to 12, means it will be completed 1 hour. That means one full circle it will be completed. One full circle angle is 360 degree. Then angle covered by the minute hand in 1 minute. 1 hour means 60 minutes. Then 60 minutes means 360 degree. From 60 minutes, if you want to write angle subtended by the minute hand in 1 minute, means just divide 360 with the 60. 360 by 60, that is equal to 6 degree. That means in 1 minute the minute hand will turn 6 degree. But we need 5 minutes how much angle it will be covered. So angle covered by the minute hand in 5 minutes. In 1 minute the angle is 6 degree. 5 minutes means 6 into 5, that is equal to 30 degree. Once again, one complete rotation means 1 hour complete turning, means the minute hand will take 360 degree rotation. Then 1 hour means 60 minutes. 60 minutes it takes 360 degree rotation, okay, angle. Then from 60 minutes, if you want to convert to 1 minute, for 60 minutes 360 degree. That means for 1 minute divide 360 with the 60. So 360 by 60 is 6 degree. That is for 1 minute. We are asked to find out the area swept by the minute hand in 5 minutes. Means angle we need, how much angle it will be covered in 5 minutes. That's what we have to find out. In 1 minute 6 degree means in 5 minutes 6 into 5 30 degree. So angle we have got 30 degree. So theta 30 degree, radius 14 centimeter. So area swept by the minute hand is area of sector, the shaded portion. So theta by 360 into pi r square is the formula. Theta we have got 30 degree divided by 360 into pi. Pi is 22 by 7 into radius is 14 square. Then 30 by 360, of course we can do the calculation there. 30 into 360 we can cancel it 12 times. And here 22 by 7, 14 and 14, that just to keep as it is, okay. 22 by 7 is we have written as it is, 14 square we have written 14 into 14. Then we can do the calculation on the this portion, second step, that is here it will be going for 2 times, and here when we cancel 2 it will be coming 6 times, this 2 we can cancel, and then here 6, if you cancel 2 it will be coming 3 times, it will be coming here 11 times. So there is nothing more to cancel. 11 into 14, that is 154. 11 into 14 is 154 divided by 3 centimeter square. So 154 divided by 3 centimeter square. If you don't know the mental calculation process, like 11 into 14, if you don't know, that is 154. Multiply and write, okay. Don't copy the answers and complete your work, complete your task, because it will be a problem when you appear the examination. So 154 by 3 centimeter square, that is the required area. Next we shall discuss the 8th question. A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the horse can graze. Pi value we can take here 3.14. So this is the diagrammatic representation. A horse is tied at a peg at one corner of a square shaped grass field. So here a horse is tied at this end of a square shaped grass field, and by a 15 meter field of side 15 meter, means the side of the square field is 15 meter, of a 5 meter long rope. So the length of the rope is 5 meter, okay, length of the rope is 5 meter. So we have to find out the area of that part of the field in which the horse can graze. So how much area the horse can graze? The horse is tied at this end, and the length of the rope is 5 meter, and how much area within this square field this horse can graze, that is the question. Means clearly it is a sector, it is formed. Angle here it is, since it is a square field, answer the angle here is 90 degree, and radius means the length of the rope, that is 5 meter it is given to us. So easy to calculate, just find out. Means when you see the diagram or when you separate the diagram, the sector form is like this. This is the portion we need to find out the area. Radius of the circle that we can consider as 5 meter, and angle we can consider as 90 degree. Let ABCD be a square field and length of the rope is 5 meter. These are the given things. So length of the rope 5 meter means in the sector case we can take radius as 5 meter. Then angle QBP is equal to 90 degree. That means the reason is in a square all angles are 90 degree. Then area of the field which horse can graze is equal to area of sector QBP. This is the sector we are going to calculate the area. That means theta by 360 into pi r square. Theta value we know that it is 90 degree by 360 into pi. Pi it is given to us 3.14 into r square. R is radius 5. So 5 square. Then 90 and 360 we can cancel 4 times. So 90 and 360 when you cancel it will become 4 times. Then 3.14 into 5 into 5 by 4. Then here 5 into 5. 5 into 5 is 25. 25 by 4. I am doing the calculation this way. Okay, 5 into 5 I can easily multiply. So 5 into 5 is 25. Then I am dividing 25 with 4. 25 when I divide with 4, I will be getting the answer as 6.25. Okay. I hope you know the division. 25 divided by 4, answer will come as 6.25. You can see. Then 6.25 into 3.14. That way I am doing 6.25 divided into 3.14 when we multiply. Here after the decimal 2 digit. Okay. Here after the decimal 2 digit and here after the decimal 2 digit. So total 1, 2, 3, 4 digits will be coming. So when we are finalizing the answer, it will be coming as 19.625 meter square. So when you are doing the calculation, you have to be very careful which one is convenient method, that way you can proceed. Here what I have done is I have multiplied 5 into 5, 25, because 25 with dividing with 4 I can do the mental calculation. So 25 by 4 is 6.25, clearly I know without division. So that's why I have taken that path. So 6.25 into 3.14, that is the only multiplication I have to do, that I have done. So here this one simply I have shown. Okay. So which is the easiest way, in which you feel it is easy, that way you can proceed. So final answer we have got as 19.625 meter square. Here also I request you, please don't copy the calculations, do it and then verify whether you are getting the answer or not. Then the second part of the question, the increase in the grazing area if the rope were 10 meter long instead of 5 meter long. Previously the rope was, the length of the rope was given to us 5 meter. Now it is increased 10 meter, length of the rope is 10 meter. How much area it will be increased? The grazing area, how much it will be increased? That is what the question. So the same thing only thing is that instead of 5 meter radius, we have to consider now 10 meter radius. That area first of all we have to find out. So length of the rope of increased to 10 meter. That means area grazed by horse is equal to theta by 360 into pi r square. Theta remains the same. Pi also 3.14 constant, only radius is changed. Instead of 5, 10. So 90 by 360 into pi into 10 square. Then as before 90 and 360 we can cut. 90 and 360 cutting means we will cancelling means we will be having 4. Then 4 into 3.14 into 10 square means 10 into 10. Then here 3.14 into 10 into 10, that means 314. 314 by 4 is 78.5. I am doing it in mentally. So what you do is, if you don't know calculation, just go with the division. Okay. So 3.14 into 10 into 10, that means 3.14 into 100, that is 314. 314 divided by 4. 314 divided by 4 is 78.5 meter square. So this is the area of when the length of the rope is increased to 10 meter. Here increase in grazing area, that is what we have to calculate. Means previously there was an area in which the horse grazed, and now at present with the increased length of the rope, the horse is grazing a new area. What is the, how much area it is increased? That is what the question. That means previous area we have got as 19.625. In the previous slide we have calculated and kept, and now we have got the new area 78.5. Just to subtract it, 78.5 minus 19.625, answer is 58.875 meter square. Okay, so this is the increase in grazing area. Dear students, today we have discussed question number 1 to 8 from exercise 12.2. Some questions we have removed because it is not included in the 21-22 CBSE board examination, and I request all the students to go through the given portions, given questions, and do the calculations independently in a sheet of paper. And while solving, if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.